Okay, so this is where we had left off with last time. So if you just see that term alkene, the very first thing that should jump out in your mind would be what? A double bond, that's right. Okay, so then if that double bond is not on the end, what does that tell you need to do then? If it's not on the, yeah, you have to have a number in front of it, right? Okay, so as we move forward then, okay, we talked about this yesterday, okay? Occurs because only one type of bond is that of for connectivity for alkanes. There was only going to be one isomer for that of butane. But butene has two isomers because you can move that double bond. And we illustrated that on, what was that, Monday? Yes. Because I think when it comes to writing isomers, it's hard for, well, it doesn't, it's not necessarily hard for everybody, but for some people, it is. But with practice, you get better with that. And maybe closer towards the end of the season, well, the knees probably felt pretty good at the beginning of the season. Now they're starting to get a little, I don't want to say swollen, inflamed more. Does that sound right? So old trainer or old doc doesn't say maybe take some chondroitin or something like that. Yeah, because your body will build a tolerance up to it. And then it's usually pretty good after just icing it down, and it's good to go. Very good, very good. Okay, so let's see here. Next, notice it's not that we fly through here. And I don't know if I ever explained why when you're looking up at these sections, with the author that we have with your hardcover book is probably actually chapter, I want to say 23 maybe, but this still comes from the same author, but it's from a soft cover book, and it was chapter 4 there. So when I had started utilizing that, that's why I just kept that the same. But just know this is just unsaturated hydrocarbons, and when we utilize examples in the book, then we point that out. Okay, so I want to look at this and this. Man, I didn't think there's that many. Okay. Okay. Go through this example or this slide, and maybe one or two more. And then I do have some reactions up on the board. So as you can see, as far as naming these, there's really not a whole lot that's changed. The suffix, and then once you get past 4 carbons, if that double bond is not on the end, well then you need to be able to illustrate or explain where that double bond is. And I got some examples up on the board, and we'll be going over them in just a few minutes. So as we go on here, these are common names, as you can see. Like we wouldn't call it ethylene, that's the common name, but the scientific name would just be not ethane, but ethene. not propane, or excuse me, not propylene, but propene. So these are common names, very much like natural gas is a common name for which hydrocarbon. It's the simplest one. You're going to hit yourselves over the head and say, God, I knew that. The simplest hydrocarbon compound. And how many hydrogens? So that's what? Methane. See, sometimes, and I'm not saying we made it too difficult, because to me, again, the difference between this organic class and inorganic, of course, there's no math really involved in here. It's just more concepts, and I do believe there's more to remember. Yes, there are steps that you utilize in, for instance, molar mass problems last year or stoichiometry, but those patterns tend to repeat themselves. I think everyone would agree with that, where with these we're always adding new information, and there's going to be different rules that you have to apply to not just naming these, but utilizing the reactions as well.
This afternoon, all students are going to the cross-country meet, okay? As long as we act like good citizens and cheer for our schoolmates, okay? Right, well, about 12:50-ish. See where you're at the end of the SRP and from there. Should be good. I only have about 5 or 6 teachers that will be able to watch everyone, so just don't make it a job.
So as we move forward then, okay, I want to do this one, that one, and then we will stop there. I just want to go through these two slides. Okay. I'm trying to think of what our next activity is. I believe it's hand cream or lotion. It's not this week, of course, and it probably won't be next week either. But with some of the products that you may use at home, at one time, farmers would utilize everything they had on the farm. And I don't know as far as processing your own beef or pork, you know, when it comes to living on a farm and with your family, I'm sure, did you haul maybe a steer to Madison or to Renner or wherever? And I don't, did your dad ever do his own butchering before? And it's tough to do that if you don't have the equipment. If you have the equipment to do that, it's not so bad. It's a lot of work, but I mean that's fine. But I think, you know, when said your grandma's the best, she said, I got an answer for you. Was that bonus question about sports teams? And I would think, well, I agree, but I would think that if you, so did she grow up on a farm then that you know of? Your grandparents over here that you know of? That you know of? Okay, the reason I say that, have you ever dealt with sheep before? Because I haven't. I know this is true when it comes to dealing with these sheep, when you have to shear them, your hands are going to feel really greasy by the end. That's a compound called lanolin, and we use that with a couple of other components to make hand cream, and it's really good because, you know, it's organically made. There's no unnatural products in there, but the only problem is your hands will feel greasy all day long. That's, and maybe the best time to put that on would maybe be before you go to bed, because it just leaves an unnatural feeling. Because one of the reasons that we ask, well, why do you buy the hand lotion that you do? What maybe two or three reasons come to your mind? Well, it does, but a lot of lotions do that. But why would you buy a particular brand, do you think? That's probably the number one issue right there, is it smells better. And spreadability is another one. It doesn't leave your hands feeling greasy. Those are probably the two biggest aspects. When we make our own hand cream, really you only need these 4 ingredients, and by the time you make your cup, it's probably about 25 cents worth of materials in there, but you put that into proportion. I mean, that would be even with a full bottle. So then if you have maybe 25 cents of ingredients into it and you sell it for $4.50, $5, you know, that's quite a markup. But again, people buy these products because it smells good and it hydrates your skin and it doesn't leave it feeling greasy once you're done. Okay, so final slide for today, and then I have a couple things up on the board, and we will go over them just shortly. Now, when you're looking at that and you're saying or reading, it says similar to that in cycloalkanes. We didn't talk about that last chapter. Well, you're correct, we didn't, and the reason for that is it's hard to visualize that for the first time when you're doing these with saturated hydrocarbons. Once we illustrate it here, it's a lot easier to see. Okay, does everyone have this information that wants it? Okay. Now, this will, I'm not saying come full circle, but this will, we'll put this to a practical use. So you can say, oh, so that's why that product has that associated with it. Especially when it comes to, let's say, Doritos, Pringles, Frito-Lays, corn chips, I mean. So what do you suppose those are always advertising? That buy this product because it's got 0 grams of this. I think you've seen it before, but just never realized, oh, that's what that means. What type of fats? Maybe. 0 grams of blank fats. Yeah, 0 grams of trans fats, okay? The reason for that is when the body metabolizes those, it releases a lot of what we call free radicals, and it's harder for the body to digest, okay? And it's just not as good for you, like maybe raising. So what would you rather have? Large amounts of HDL cholesterol or LDL cholesterol? Which one do you really want to have? High density or low density? You actually want to have more high density rather than low density. So the HDL cholesterol is good. The LDL, that's not good, if my perception is correct, which I think it is. Okay, so a couple things that we will make sense of this, okay? We'll go over these reactions here in just a moment, but when I was talking about those cis-trans isomers, okay, if we see what's called 2-pentene here, okay, how did it say we needed to write that? Again, this is the family, okay? That's telling you something specific, and so is that. So what does ENE mean? Somewhere there's a what? Double bond. So what does this tell you? The parent what? There's 5 carbons. And then since there's nothing written after that 2, it doesn't say 2-methyl, it doesn't say 2-ethyl or anything to that effect, since nothing comes after that number, that is referring to that double bond. So let's go ahead and put our 5 carbons in. Okay, so we can go ahead and bond these together. Okay, we know we're safe putting those in. So now, you tell me where do you want that double bond? On the left side or the right side? On the left. So that means that after our second carbon, what are we going to put there? Double bond. So there's our double bond. Okay, which I actually didn't do that right. I should have took him off. This can safely have 3. Okay. Are we done, do you think? Yes, because how many bonds does this carbon have? It only has 3. This one's got 4. 1, 2, 3, 4. This one only has 3. 2 there, 1 there. So since this is up on top, we'll put him down below. Okay, so now we've got our 2 pentene. But when it comes to cis and trans isomerism, you pick. What do you want, cis or trans? Cis. So what that means then, we start with this. There's our double bond. Okay? So right here is what we're referring to. We're putting that up here. So since we said cis, we're going to put a methyl group, well, not methyl group, but there's that carbon up there. Then here's that hydrogen. Okay? Then here's that hydrogen. And then here is. That's the difference between 2-pentene, and this is also 2-pentene, but it's called cis 2-pentene because it's a bent molecule like this. Okay? And the reason that we call it cis is we want to look at the hydrogens, the way that they're bonded. Okay? Now, that might not make any sense the way we look at it now, but when we see the trans compound, we're still going to draw the same thing, okay? But what that means is this. Now we're going to go ahead and we're going to leave him up here. Okay? So what do you notice is the difference between these two? Remember, what do we say here? We want to go by the hydrogens. Well, what's true about the hydrogens here? One's on top, one's on the bottom. Okay? So when it comes to cis compounds, it's like both hydrogens are pointing down. Okay? When it comes to a trans compound, one's pointing up and one's pointing down. One way you can look at that is when you think of, my history and geography isn't the way it's supposed to be, but like the Transcontinental Railroad, that was in, I'm going to turn my mic off now so people don't make fun of me if they hear this. Yes, the Transcontinental Railroad then, just picture, meant it went all the way across. Okay, what we mean by that, it's going up in this manner. These are as far apart from each other as possible. Okay, so it's kind of like a zigzag, where with a cis compound, it just forms a U. You can either remember it that way, or you can go by the hydrogens. Okay. That's the difference between cis and trans compounds. Okay, so then when we refer to them in the cycloalkanes, let's look at, for instance, cyclobutane. Using that knowledge that you just learned, would you think this would be cis cyclobutane or trans cyclobutane? You sure? Some students don't like it when I do that, some people. Because they answer the question and they're right, and I go, well, you sure? Then they second guess themselves. But yes, that's cis cyclobutane. Okay? When you look at these hydrogens in this cis-2-butene, those hydrogens are doing what? Pointing down. Okay? And the two branching chains are pointing up. These are both pointing up. These two are pointing down, just like what we see here. So that's why that would be cis cyclobutane instead of trans, which would mean then you'd put a methyl group down here. That only occurs when you have two derivatives on there. Should we have this, then you wouldn't have to worry about that. But this would be trans cyclobutane. We don't spend a whole lot of time on it with the alkanes because it's more important with that of the alkenes. Okay, so we kind of lost a little bit of time, but we will pick up with this tomorrow, these three reactions. And when you had asked about the symmetrical reagents, was that one of your questions? Okay. So one way to look at that, and that's why we wanted to write these reactions like this, because you got to remember what's true about these three elements. When you learn it in physical science, you applied it then, you applied it in general chemistry. Now you're going to apply it with organic. What's true about gases and halogens? Starts with the letter D. They're diatomic. So that means when you write that, okay, when you write hydrogen, we know it's H2. So that's H2. Then this is Cl. And we did that last chapter, okay? On either side of that bond, that is symmetrical. If we understand what symmetry means, it's the same on both sides. So the difference between the symmetrical reagent and the asymmetrical is that. Okay. This is the symmetrical type. This is the asymmetrical type. Okay. It's how you're looking at the bond. Just picture it being a mirror image of one another. On this chlorine to chlorine bond, it's chlorine on both sides. But if it's hydrogen chloride, it's the asymmetrical type. You have a chlorine on one side of the bond and a hydrogen on the other side. So that's what makes this the asymmetrical reagent, this the symmetrical reagent in your vocab terminology. We will continue with this tomorrow.